Hello, welcome to this video produced as part of the Further Maths Support Programme's material for A-Level Maths and Further Maths. This one focuses on work done by a variable force. Let's begin by reminding ourselves of the elementary definition of work done. It's the force times the distance moved if the force and the distance are in the same direction and if the force is constant. If we want to apply the idea of work done to a force which is variable as the distance changes, such as with the tension in a stretched spring, we need a more sophisticated approach. So let's take a force acting upon a particle, and we'll take its movement to be over a distance x measured from some origin. Let's take the initial position that we're considering as where x equals x1. So at that moment the force applied will be Fx1. There's a graph on the left which shows the variation of force over distance. Let's say we start at A and we finish at B. X equals A to x equals B. We're at some intermediate position x1. Now if we displace our particle a bit to the right, a distance x, delta x say, so that distance is delta x, we're moving to a position x1 plus delta x for x, then the force will be at the beginning Fx1 and the distance is delta x, so we'll take Fx1 times delta x as our first shot at the work done. Now on the left that represents the area of that rectangle, because the vertical line which I'm marking with a dot will be represent the value Fx1, and Fx1 times delta x gives us that area. Now having got to our second position where x equals x2, we can repeat it again using the value Fx2, which will give us a second strip. So that will take us to x1 plus 2 delta x, and we'll get an approximation for that strip as well. Now you'll recognize this as a standard calculus procedure. We take enough strips to fill up the entire area from A to B, and what we're doing is essentially working out a first approximation to that area. So for this more sophisticated approach, what we do is use that idea to say that we define our work done in terms of an integral. That's what would happen if we let the strip sizes get smaller and smaller and take more strips. So we're saying that the area is going to be the force integrated over the distance x between the starting point x equals A and the finishing point x equals B. So let's apply that approach then to a simple case here where the force is defined by this relationship between F and x, and we're moving from x equals 0 to x equals 4. So the work done will be the integral of the function's relationship, the force's functional form with respect to x between 0 and 4. Well, that's the difficult bit, the conceptual basis for writing that down. After that it's a matter of drill. So we'll get as usual 4x squared minus 3x in square brackets from 0 to 4, and we work it through with the arithmetic, which gives us that formulation. You'll see that 64 minus 12 is the evaluation of 4x squared minus 3x at x equals 4, and the lower limit trivially gives us 0. So the end result is 52. So the work done in that particular piece of that situation where force moves variably, force is variable over a distance, is in this case 52 joules. That brings this video presentation to an end, and it's the final one in this series.